Here is our next video involving the binomial distribution. Let's take this example. A spinner is designed so that the probability it lands on red is 0.3. Jane has 12 spins. Find the probability that Jane obtains no more than 2 reds and at least 5 reds. So we can do this quite easily. We can say that that's the same thing as the probability that x, if it's no more than 2 reds, that means that the probability of x must be less than or equal to 2. And we can get that directly from our calculator. So menu, option 7, go down to binomial CD, and then we notice that she has 12 spins. So x must be 2, and n is 12, and p is 0.3. And that will give me 0.2528 to 4 decimal places. And then you want to do part B, at least 5 reds. That's the probability that x is greater than or equal to 5, which is the same thing as 1 minus the probability that x is less than or equal to 4, which is 1 minus. So on our calculator again, change that to 4, and we're going to store this value 0.7236 and so on our calculator, and store and A, and then go back to the main menu and then do 1 minus alpha and A, and then we get 0.2763. So 0.2763 as our answer. Now in the next part it says Jane decides to use the spinner for a class competition. She wants the probability of winning the prize to be less than 0.05. Each member of the class will have 12 spins and the number of reds will be recorded. Find out how many reds are needed to win a prize. So because the question states it needs to be less than 0.05, we make this inequality to be less than 0.05. Now we can't do the probability of x is greater than or equal to n, because by default the binomial distribution is always less than or equal to. So we do the converse of this, which is 1 minus the probability that x is less than or equal to 1 less, which is n minus 1. And that's going to be strictly less than 0.05. Now, if I was to rearrange my inequality, I get 1 minus 0.05. That's strictly less than the probability that x is less than or equal to n minus 1. So we're saying that 0.95 is strictly less than the probability that x is less than or equal to n minus 1. But what does it mean for 0.95 to be strictly less than the probability of x is less than n minus 1? Well, in everyday life, if I said to you 2 was less than 3, which it is, another way of saying that is 3 is greater than 2. So we can say in our case the probability that x is less than or equal to n minus 1 is strictly greater than 0.95. Now I've mentioned these binomial distribution tables to you before in previous videos, stating it was in the formula book. So here's an example of how we're going to use it. So we know that n in our case is 12 and the corresponding probability is 0.30. So what we're going to do is we're going to go to n equals 12 in our table, go across to 0.30, and what we're going to do is we need to find the first value that's strictly greater than 0.95. So I'm going to get my highlighter and do that. So where is the first value that's greater than 0.95? So if I scroll down, I can see that it's this value. So what I'm going to now do is say, well, the probability that x is less than or equal to 6 is equal to 0.9614. So I can write that down here, that the probability that x is strictly less than or equal to 6 or in other words, probability that x is less than or equal to 6, is 0.9614. So 0.9614. So now what we can tell the examiner is, since, and we write this in words, okay, very clearly to the examiner, since 0.9614 is strictly greater than 0.95, we can say therefore n minus 1 must be equal to 6, and then we can say therefore n must be 7. Here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, welcome back. So we can write this as the probability that x is strictly greater than or equal to s, which is less than 0.01. We could rewrite that as 1 minus the probability that x is less than or equal to s minus 1, which is strictly less than 0.01. Rearranging our inequality, we get 1 minus 0.01 is strictly less than the probability that x is less than or equal to s minus 1, which is 0.99, is strictly less than the probability that x is less than or equal to s minus 1. In other words, we could write that as follows, as we could write that as the probability that x is less than or equal to s minus 1, which is strictly greater than 0.99. So that means in our tables we need to go up to n equals 10, and 0.30 is 1, 2, 3, 4, 5, 6, the sixth column down. And so we go across 1, 2, 3, 4, 5, and 6. So we need to find the first value that's strictly greater than 0.99. Well, that's going to be this. So we can write that as the probability that x is less than or equal to 7. Let's just write that down here. So the probability that x is less than or equal to 7, and we can write that probability down from our tables is 0.9984. And we can make it clear from the examiner this is from the tables. So we can say since 0.9984 is strictly greater than 0.99, what we can say from there is therefore s minus 1 must be the same as 7, and then we can therefore conclude therefore s is 8, which is the number required.